Okay, this is MAC 1114, section 6.1. We're going to be looking at all the basics that you're going to need in order to function throughout the entire course, like how to convert angles from degrees to radians, how to rotate around the circle. If you remember from geometry, you were studying quite a bit about circles and right triangles. I mean, there was a lot of doing proofs in that class also. We won't get into that, but we will mainly concentrate on circles and triangles. And in order to know how to draw those triangles inside the circle, you first have to master how to rotate. In order to create certain types of angles like negative angles and positive angles. So we're going to start off with just some diagrams that kind of give you a feel for that. Then we'll get in to some conversions. We'll also get into some formulas that were actually in your geometry class. But again, you've probably taken that back in 9th or 10th grade. And so I will review them with you here. They are part of section 6.1. So 6.1, instead of being one specific sort of topic, it's kind of a potpourri of various little skills that you're going to need in all of the rest of the sections. Okay, so we start off with some pictures of what it means to create an angle and which way you're rotating and how that determines whether it's a positive or negative angle. As you see in this first picture, you have two rays, as they are called, if you remember from geometry. Two rays that connect at a common vertex are what you need in order to create an angle. The angle is in between the two rays. In trigonometry, what's going to happen is that this vertex is eventually, when we start moving inside of a circle, it's going to be fixed right at the center of the circle. We will also be superimposing our circles right on an XY axis. And soon you'll see some pictures of that. But right now, I'm just giving you just some basic pictures. Then we'll move to the XY axis. When that happens, this point will not only be at the center of the circle, but it will be right at the origin of an XY system. Because eventually we're going to relate these pictures to the quadrant that we're landing in order to know what is negative and what is positive, but that's more or less in section 6.2. So for right now, know that you need two rays in order to create an angle. And in trigonometry, one side is going to stay pasted. It will never move to the x-axis. It's going to stay fixed to the x-axis, and that side is always called the initial side, while the other ray rotates. And it can rotate to the first quadrant, second quadrant, third quadrant, fourth quadrant once we do start pasting this to an XY axis. So this will be the rotating side. Oops. And this is going to stay fixed. And that's always going to be the case. Okay, now, how do you tell whether it is positive or negative? You can see from the descriptions that I've given you right here. The way this angle is formed is that these two rays, they start off right on top of each other, pasted to each other. One stays fixed to where it is while the other one rotates. So because this terminal side rotated in a counterclockwise fashion, which you can tell by that arrow, they're trying to show you that this arm right here spun in a counterclockwise fashion. It rotated this way. And because of the way it's rotating, the direction in which it's rotating, we say that this angle, they use the Greek symbol alpha here, and that's pretty much the convention, that they're going to be using various Greek symbols. This is alpha, beta, omega, theta is another real common symbol that's going to be used. But anyway, the direction in which the terminal side was rotating dictates the fact that this is a positive angle. There's the angle right there in between the rays. Whereas in this problem, again, the angle is formed by one side rotating while the other side stays fixed. So both of the arms, again, they started right here, pointing in an X-like direction. One arm stays here while the other one rotates. So this time what was happening is the rotation was going this way, clockwise, until it ended up landing right here. So because it's a clockwise rotation, and again, you could tell it's clockwise because you can see that they're showing you that it's rotating the way the hands rotate on a clock. So there's your angle out there. And because the rotation that created this angle was clockwise, that means that it is a negative angle. So whatever that however many degrees this is, and we'll start dragging numbers into these problems. Let's say that that was a 300-degree rotation. We would say that it was negative 300 degrees. Let's say that we knew that this was 60 degrees right here, that little angle in the first picture. Then it would be positive 60 degrees. Okay, so all that enables you to do, knowing which way you're rotating with your terminal side, is to give it a negative or a positive on the angle. In this problem, what they're trying to show you by way of this picture, and you're going to have to pick from multiple choice pictures for the first 3 problems, is that they're trying to show you that they went full revolution all the way around the circle. They're trying to show you that they are rotating by way of this little arrow in a counterclockwise fashion, rotating the opposite of the way the arms rotate on a clock. So that terminal side is what they're talking about. It rotated this way, all the way around, and then a little bit more. So that's called going full revolution and then going extra. So any number that they did give you with respect to this rotation would have to be something bigger than 360. Like maybe this is an extra 30. So that would be an angle of 390. And since it's rotating in a counterclockwise fashion, it is said to be a positive angle. So it would be positive 390 if that little extra bit was 30. These are just more pictures also of rotations. This time I'm calling the angle theta. And again, they're just pictures of various kind of rotations. Again, these 2 arms were pasted to each other at the beginning. One always stays pasted to the x-axis while the other one rotates. That rotation that you see right there is a counterclockwise rotation. And therefore, because this is counterclockwise, whatever this angle is as a number, let's say it's 110, you know it's got to be more than 90, because when you rotate from here to here straight up where the y-axis is, that's 90. So you can use these what are called landmarks. This is a landmark, that's a landmark. We'll talk more about that to judge sort of where you're at. So this would be something bigger than 90, let's say 100, 120, something like that. But anyway, it would be positive 120 because of the way the arm, the terminal side, is rotating. Okay, next picture. Just another picture, just so you get familiar with it, that these angles will be created by 2 rays. One ray will stay fixed at the x-axis. The other one will rotate. The vertex will always stay right at the origin when you have superimposed your picture on an xy axis. So what happened here is 2 arms started like this, right on top of each other, coincidental rays, and one began to move, the one called the terminal side, until it was right here. So because this was created by the terminal side dropping down and rotating in a clockwise fashion, we call that a negative angle. This one was positive because it was counterclockwise. This one's negative. So let's say that you knew that this was 120. This would be negative 120. Let's say you knew that this was 120. Because of the way it's rotated, we would say that this was positive 120. And you know when something's positive, you don't have to put the positive there. It's optional. But when it's negative, of course, you do have to put it. So those are some pictures of positive and negative angles. When you go to the next page of the theorem page, and by the way, if you read my announcements and some of my information about getting started in this class, whenever you're taking notes, whether it's face-to-face, synchronous, or completely online, you want to go into the content folder, and you'll see that there are outlines for every section. And right in that same folder, it's a homework outline, and then right after it, or right next to the two, come right after each other, is the theorems that go with it. You need to be looking at the theorem pages first, getting yourself familiarized with the theorems, and then every so often on the theorem page, it'll tell you, okay, now break away and go do numbers such and such in the homework. So we haven't gotten to that point yet. We're still familiarizing ourselves with these pictures and just getting used to superimposing these angles that we're going to be creating on an XY axis. So now in these pictures, I get more detailed. Not only do I have pictures of negative and positive angles, but they're also superimposed on an XY system. And I start to point out or remind you, because it's not that you don't know this, what the names of the quadrants are. When this arm stops, you're going to see that we are headed for, as soon as we get to section 6.2, we're already going to be doing this. We're going to be taking this and putting it inside of a circle. We're going to draw the y-axis right through the circle and the x-axis right through the circle. So we'll be drawing right triangles inside a circle. So they'll just be, they'll be like a circle around here. We'll put the center, the vertex of the angle right there at the origin. We'll keep one arm fixed to the x-axis while the other one rotates. Depending on which way we rotate, this is a counterclockwise rotation, the angle will be positive or negative. But what we're going to do is use this angle ultimately to find the angles inside of triangles. Now you might say, well, where are the triangles? The triangles are going to be created like this. And I kind of didn't draw this circle big enough. Right where the ray stops, you're going to head for the nearest x-axis. And you're going to travel to the nearest x-axis at a 90-degree angle, perpendicularly. This leg, these are called legs, the legs of a right triangle, the two sides that meet to form the right angle. This leg is going to represent your x coordinate, because we're going to start getting into x and y coordinates. I'm kind of just pushing you ahead so you know why I numbered these quadrants. And this leg that goes up and down, even when this triangle is upside down, the leg that goes up and down is going to represent your y coordinate. And the leg that goes horizontally is going to represent your x coordinate eventually. And depending on which quadrant you're in, do you remember that depending on the quadrant you're in, that determines the signs of the x and the y coordinate? Like when you're in this quadrant, x's are positive and y's are positive. Everything in the first quadrant has double positives, positive x, positive y. When you're in this quadrant, and how do you tell what quadrant you're in? Based on where this arm stopped, this thing called the terminal rotating side, the side that moves, which does end up being the hypotenuse of your right triangle. So when you're in this quadrant, x's are negative, you're in negative x territory, and y's are positive up here. So we have to get refamiliarized with that. I mean, that's pretty basic. When you come, if you end up with a triangle down here, let's say you rotate all the way to this quadrant, to quadrant 3, you know that x's are negative in quadrant 3, and so are y's. If you're in quadrant 4, like you are in this picture right here, again, how would these triangles be created? You would just go from the edge of the ray. This is the rotating side, the terminal side. This angle just happened to be created by having two rays on top of each other, rotating side rotated to here. But when we do start drawing triangles, you're just going to head for the nearest x-axis, approaching it at a 90-degree angle. This leg that runs up and down will represent the x. This will represent the y. And the way that we'll know whether to put negatives on the y and the x is based on the quadrant you're in. See, when you're in quadrant 4, x's are positive anytime you're over on the right side of the y-axis, and y's are negative. So we'll pay real specific attention to that